In this video, we're going to summarize some properties of vector product, and there are certain videos that I already discussed about the concept of vector product, and indirectly I've already explained the usage of the vector product, alright, and the properties of vector product in details in some videos. So now I just summarize for you what is the vector product. That's very important. So the first thing that we have to remember that cross product or vector product is defined to be the cross A cross B is the magnitude of A, magnitude of B, sine theta multiplied with a unit vector which is in the direction of A cross B. Alright, it's a unit vector for this unit vector for A cross B is to tell you that this is also tell you that this is a direction, okay, of A cross B. Is a vector, right? It's a vector product. You are producing vector. So since all this is scalar, there must be a vector to support this definition here, right? So, and this vector product, you can rewrite it in the form of magnitude, right? I have already explained. So you can rewrite it as a magnitude of A, magnitude of B, sine theta, and definitely the magnitude of the unit vector here will giving you 1. That's why I never write anything here, because it's already turned to 1 when we convert it when we want to calculate about the magnitude of A cross B. And okay, now let's using this definition. We have some important. Okay, the first property here will be, we have learned that A cross B is B cross A. They are not the same, right? They are not the same. So means that this is, we said is not commutative, right? It's not commutative because why? A cross B is not the same as B cross A. This is wrong when I'm writing this, right? But if this is A dot B scalar product, then this is true. If they are different, because why? Even though the magnitude are the same, the A cross B and B cross A, the magnitude are the same, but they are actually opposite direction, right? They are opposite direction. I have already explained in another video. Right? So in first, I want to explain about there's some properties that you must know. For example, if I said A cross with A, right? Definitely you know that A vector A and vector A, they are two identical vector, right? Then they are also parallel. They are equal vector, right? They are equal vector. So means that A cross A, magnitude of A, magnitude of B, sine 0, theta is 0. The angle between these two vectors is 0 because they are parallel and in the same direction, right? So if this sine 0, everything will turn to be 0, and 0 multiplied with any vector, right? 0 multiplied with any vector, okay? It will become 0i, 0j, 0k, right? Which will giving you 0 vector. This is very important. So any identical vector, A cross A, B cross B will turn out to be a 0 vector. Not a 0, but it's a 0 vector. So, and thirdly, let's say if I have A cross B, okay, I will summarize the important one first, right? Later on there is many more, right? But this is the one that's famous in your examination. So if you have A cross B happen to be a 0 vector, suddenly if you cross two vector, let's say if you do cross product, cross of the two vector, you're getting a 0 vector, right? So this one can conclude that vector A is parallel to vector B. Either they are in the same direction or they are opposite direction. The parallel means it can be the scalar product, scalar multiple of another vector, right? Either these two are parallel in the same direction or opposite direction. As long as you cross these two vector, you're getting 0 vector. These two vector must be definitely a parallel vector. Means that vector A is parallel to vector B based on the cross product here. Okay, another important properties here will be, okay, let's say if you have you previously have shown that A cross B is always perpendicular to any vector that involving in the cross, right? For example, these two vectors. So if you dot with A, you are getting 0 because vector A cross B is a normal vector for vector A. And vector B, and it's also the same if you take A cross B dot with B, you are getting 0, right? Getting 0. So as long as A is involving in the cross product, then if you dot with this vector, you are getting 0. That's another one, but I'm not going to writing here. All right. So this one I already explained in another video. So let's say if you have A cross B plus C, A cross B plus C. So if you have A cross B plus C, this one is said that is actually distributive. We said that cross product is distributive across addition. Means that we just like can expanding this A cross B plus with A cross C, right? A cross C. So, but we are doing cross product for each of these vector. So they are actually giving the same result. All right. All right. And let's say if you have A dot with B cross C, right? Actually, A dot with B cross C is actually represent the volume of a parallelepiped. Means that a 3-dimension, okay? The volume of a parallelepiped. All right. As you're taking this cross, the vector A cross with vector B, we get the area. We get the area of the parallelogram, right? As we're taking these two, let's say B cross C, we're taking cross this into, we're getting the area of parallelogram. And after that, we're getting the area, right? The area is a scalar, yes, no? It's a scalar. So the area here is is another vector, sorry. It's another vector. So vector B, when you cross with vector B, you will produce another vector, right? Because B cross C will produce another vector. So another vector dot with another vector, you are getting a scalar, right? Scalar. So it means that these two vector when you cross, you're getting another vector. And this vector, when you the vector that you get after you cross, you cross with another vector. You dot with another vector. You will find out to be a scalar quantity. The scalar quantity is actually represent the volume of the parallelepiped. Alright, it's a prism. Alright, it's a prism actually. So prism with the surface of parallelogram. Okay, the front surface. So or you can rewrite this to be like A cross with B. It can happen to be this way: A cross with B dot with C. It's the same thing, right? So means that A cross with B dot with C, or you can do B cross C dot with A. They will get the same scalar. All right, means that okay. If you can try to read more in any website or any books. So if you take the side here, and this side here, this is also a parallelogram. All right. So if you cross A cross C, all right, A cross B, this will become your height, right? So you were still getting a volume of the parallelepiped. So these two were always valid. Okay, and another one, this is least important, but it's complicated to proving this and use these properties here. So just for your knowledge, you have another property which can be A cross B cross C is the same as A dot C B minus with A dot B C, right? So you see that A cross B cross C, right? So definitely you will produce another vector. This is a scalar quantity because you cross, you get a vector, right? A vector dot with another vector, you're getting scalar. But this is a vector, and B cross C also produce a vector. Vector cross with vector, you're getting a vector quantity, alright? That's why you see the scalar quantity have to multiply with the vector quantity, right? So, and these two this three is very important in your and this one also is very important in your examination. Alright, let's look at another properties which can be this way. Let's say that you have a scalar, M is a scalar. Then you have A cross B, right? A cross B. It's the same as you take the scalar, multiply with the multiply scalar. This is a scalar multiply, okay? The vector cross the vector B is also the same as the vector A cross with the scalar multiple of the vector B. Okay, they will all bring the same result. Alright, I think that's all the property that you should know. And I want to highlight that throughout all the properties here, okay, these 4 properties, especially the first 3, is top classified. Alright, it's very important for your matriculation level to understand, or STPM to understand this concept here. Right. For this, you can further understand by viewing more knowledge from books or website. All right, if I having time, I will try to explain the concept here. All right, and this is very important, so you have to take note about this. And later on, I'm going to do, you have to know how to compare between the scalar product and vector product. What is the difference between vector product and scalar product? It's very important for you to really understand the properties of both product, right? So that's all for this video.